Hello, dear students. Today I am going to solve a sample paper of mathematics for class plus 2 for term 2, and this is for CBSE students specially. As we know that the pattern of question paper will be of 40 marks. There will be 6 questions of 2 marks, 4 questions of 3 marks, 4 of 4 marks. So total questions will be 14 and the total marks will be 40. So for section A, we have the questions like here. First question is integrate cos 2x upon sine square x cos square x. So this is our first question. This question will be of 2 marks. We know that the formula for cos 2x is cos square x minus sine square x. We'll write sine square x cos square x as it is. In next step, we'll divide cos square x by sine square x into cos square x minus sine square x upon sine square x cos square x. Here we cut cos square x by cos square x and sine square x by sine square x. So we have 1 upon sine square x minus 1 upon cos square x. As we know that 1 upon sine square x is equals to cosecant square x and 1 upon cos square x is equals to secant square x. Now the integration of cosecant square x is minus of cot x and integration of secant square x is tan x. Here we add c as arbitrary constant. It could be the answer, but if we want some more simplification, then we can write cot x as cos x upon sin x. We take negative sign out of the bracket, so we'll write positive here, sin x upon cos x. So LCM of sin x and cos x is sin x cos x, and here we get cos square x plus sin square x, which is equals to 1 upon sin x cos x plus c. So in next step we'll write 1 upon sin x is cosecant x and 1 upon cos x is secant x. So we can write secant x into cosecant x plus c. This is our answer. It can also be the right answer. In 2 marks, we can write up to this. So next question, this is the OR part. There is option, either we can do the first sum or the Second part of question is limit 2 to 8 cube root x plus 1 upon cube root x plus 1 plus cube root 11 minus x. Here we'll use the property a to b. If we have integral a to b f of x dx, we can write a to b f of a plus b minus x. So if we use this property, limit will be same 2 to 8 and 2 plus 8, that is a plus b. Here a is 2 and b is 8. So 2 plus 8 is 10. We can write cube root 10 minus x plus 1 upon, we'll replace x by a plus b minus x. 10 minus x plus 1 and cube root 11 minus x is replaced by 10 minus x. A plus b, 2 plus 10, 2 plus 8, that is 10. So we'll get 2 to 8 cube root 10 plus 1 11 minus x upon cube root 10 plus 1 11 minus x plus cube root 10. 11 minus 10 is 1, and if we multiply the bracket by negative sign, we will get positive x. Now we'll write, this is number 1 and number 2. So the next step is adding number 1 and number 2. This is again the value of I. This is I. This is again the value of I. The similarity is denominator of both number 1 and number 2 are same. X plus 1, x 1 plus x, that is 1 plus x. So when we add, the left side will be added to left side and the right side will be added to right hand side. So we'll write it as, left side is I plus I, that is 2i, and right hand side integral in both number 1 and number 2 are same. So I'll write 2 to 8 as one integral. As the denominator is same, so x plus 1 11 minus x cube root. When we add, as the denominator are same, numerator will be x plus 1 cube root and 11 minus x cube root. Numerator is cube root x plus 1 plus cube root 11 minus x. So numerator and denominator will cut each other as the terms in numerator and denominator are same. So we have 2 to 8 1 dx, and we know that integration of 1 is x. Limit is from 2 to 8. that is 8 minus 2, 6. 2I is equals to 6. This implies that we have I equals to 3, that is 6 upon 2. I means the value of integral. So we have the answer of the given integral is 3. Come to the next question, which is question number 2. In this question, we have to check whether the given differential equation, which is 2y e raised to power x upon y dx plus y minus 2x e raised to power x upon y dy is equals to 0 is homogeneous or not. Here is the question mark. We have to check this equation is homogeneous or not. For this, we'll first write the value of dx upon dy. We can also write the value of dy upon dx, but as we have x upon y, we can write dx upon dy. Dx on left side, so the multiple of dy will be on right hand side. If we'll go on right hand side, the negative term will be positive and the positive term will be negative. 2 x e raised to power x upon y minus y, and the multiple of dx will be upon on the right hand side 2y e raised to power x upon y. Here the function on right hand side is the function of x and y. So we have f of x comma y is 2x e raised to power x upon y minus y upon 2y e raised to power x upon y. If we want to check the given equation is homogeneous or not, we'll replace x by lambda x and y by lambda y. So we can write x as lambda x e raised to power lambda x upon lambda y minus lambda y. We have to replace x by lambda x and y by lambda y in order to check the homogeneity. 2 lambda y e raised to power lambda x upon lambda y, and if lambda is taken out from the equation with some power, that power will be called degree of homogeneous equation, and if we will be able to get lambda outside, then the equation will be homogeneous equation. So here lambda is common throughout the equation, so we'll get lambda 2x e raised to power x upon y minus y. Lambda we can get also in the denominator, so we'll have 2y e raised to power x upon y. Here we have lambda raised to power 0, and this is the same function, that is f of xy. So when we replace x by lambda x and y by lambda y, we have lambda raised to power 0, that is degree of homogeneous equation is 0, and lambda is outside the brackets, that is common. So this equation is homogeneous differential equation. This is homogeneous differential equation. Now next question, which is very simple. Write the direction cosines of the vector. I can write vector as a vector, which is 2i cap plus j cap minus 5k cap. We have to find the direction cosines. Direction cosines, we know that dr's of the vector, given vector, are minus 2, 1 and minus 5. As the magnitude of the given vector is 4 minus 2 square, that is 4 plus 1 square, coefficient of j, that is 1, 1 square is 1, and minus 5 square is 25, which is 30. So when we divide each of the dr, that is direction ratio, by the magnitude of the given vector, we get direction cosine. So direction cosines are minus 2 upon square root 30, 1 upon square root 30, and minus 5 upon square root 30. If the question was find DRs, that is direction ratios, then our answer was minus 2, 1 and minus 5. But now the question is find the direction cosines. So when we divide each of the direction ratio by the magnitude of the given vector, we get the direction cosines.